This is Dr. B, and in this lecture, let's take a look at taxol, also known as paclitaxel. It's used for various types of cancers. These can include breast cancer, lung cancer, ovarian cancer. It can also be used to treat the sarcomas that form when for HIV positive people in their later stages, known as Kaposi sarcoma. So this can deal with some pretty serious ailments. The substance is a natural product, highly complex, multiple chiral centers, originally discovered in 1971 as being active against various types of cancers. This was a natural product assay that people used to perform more often back then. 21 years later, it got FDA approval, and its source is from the Pacific yew, shown here, and here's some botanical art showing some details of it. The mechanism of action is believed to be inhibition of microtubule formation, which form in cancer cells. The current source is now semi-synthetic. This structure was difficult to obtain in quantity from the Pacific yew directly. It is now obtained semi-synthetically, which is almost always a much greener, environmentally friendly technique compared to total synthesis. This substance is available from another source, and in 4 steps or so you can obtain taxol with the absolute stereochemistry intact. In order to do that, for each one of those steps you have to make sure that it's stereoselective, so it has to approach from the correct side of the molecule, if you will. In order to do that, chemists use a method known as chiral auxiliaries. The basic idea is that you modify the topology of this substance. For example, here we'll add a chiral auxiliary to it. It's a substance that's present but you want to get rid of later. And typically it is topologically selective. That simply means that it has a whole lot of surface area on one side but not the other. This would force the reaction at this site to proceed stereoselectively. Since you have one chiral center influencing another, you would have at least 2. These would be diastereomers. And so this is called diastereoselective. It gives you the correct absolute stereochemistry there. You can then remove it and you've got your chiral product. That's the idea of a chiral auxiliary, and this is a brief introduction to taxol. If you want to learn more about this and about taxol specifically, and I hope you do, there's 2 great articles that I've added here. One is called Taxol's Next Stand. This showed up in Forbes magazine in 2001. Although it's dated, it's a great introduction to some of the technical nature of how taxol works, but also the financial result of this substance. I believe it was making as many as $1.5 billion per year for Bristol Myers while it was still under patent. You may also want to look at this more recent research paper that talks about the attempts to make more selective substances for the treatment of ovarian cancer. These are the taxanes, meaning SAR studies leading to chemically modified versions of taxol to dial out some of the side effects which can be severe without affecting its activity. So a couple light pieces of suggested reading for you.